Hey everybody. So I actually have quite a few thoughts after playing around with this model for quite a bit. So I figured why not talk about it. I think the best place to actually start with this model is at the GitHub. So first of all, this is Stable LM3B, which is a model put out by Stability AI, and it's a 3 billion parameter model. And the big thing that I want to discuss with the GitHub here is their results as far as their testing and the benchmark tests. And then so what if you look at the benchmark tests for this model, it's what made me like really interested, like, oh, I want to dive into this model because these benchmark tests are like really high. Like you look at these and you claim these and read articles about all of this and like all like the news and what people always like hype is like these test results and these test scores. But and so if you look at this, you're like, oh, it's like really near like Falcon and it's above like Poppy 501.5, etc. But like the model doesn't, like these test results don't test like actuality. Like this, like it's like with their 3B model here, it's scoring like above uh, Llama 3B and other models, but like this doesn't actually like these results aren't and a score of a 35 compared to a 40, for example. I think that's a good example there, or a 41 compared to a 46. I don't really know if that like conveys what the actuality of these models are. So let's talk about that more with this stable LM3B model. So first of all, going through the model itself and the code, it took a while to set this up. So it's really straightforward. Pip-install transformers, of course, and then from transformers, I have this auto tokenizer package. Then I have to put in, you have to put in your credentials, and then I'll link this for a link. I just give a link to this in the description for the Colab, and then after this video, I'll disable the key for the Hugging Face token. You're going to want to put in your own Hugging Face token. Don't use mine, please. It won't work. And that's about it here. Once you as you're loading the model, it'll have you like you'll have to click yes a few times to like actually load through, and it'll take a bit to load up. But once it loads up, it'll load fine. But so I have two outputs here, and we can go through the outputs. One other thing that I think it's really important to highlight here. So this is the free Google Colab, and then this is running with the T4 upgrade. So you'll 100% want to make sure that you have T4 enabled. And the second thing is that you're going to get like in like instances of like I can't put anything else on top of this basically, like because you can see here in the history, like you're gonna like get real close, like very close to like fully maxing out everything at a certain point as it's loading in. Like it's gonna get like super duper close. So that's the interesting thing to me, I guess, overall, is that like, and that's why I stay interested in these models in this range, and why I've been so fascinated with models in this range is like, can we like my essential like kind of research question for myself is like, can we make models in this range useful? And I've kind of actually come to the conclusion that we can't. I think you need at least 7 billion parameters to make it useful for what we would consider like any sort of like actual purposes beyond research purposes. That's kind of the conclusion that I'm drawing, which is an interesting conclusion to draw because 3 billion parameters is kind of the max as far as consumer hardware, and then 7 billion is like really maxing out what available like consumer level hardware is and server level hardware is, like single server before you're going to like multiple, and you have to go to cloud based. So it's kind of like I wish that it lower than that, but it seems to me that we can't. And so going through the inputs of the model, the very first thing that I loaded it with was just very simple prompt. It was a dark and stormy night, and then it says it was a dark and stormy night. Well, not exactly, but it was the night of the chicken and cranberry parties, and this was the scene we found ourselves in: a lovely room with a few dozen of our closest friends and family gathered for a night of fun. So the very first thing that I noticed, and you can tell from this, is that like this is like really based off of like web-based data, of course, right? Like it's internet data, and then so I played around like with a whole bunch of prompts, and then I like this was when I ran into this one was when I decided to make the video, and so the Reddit user said, and then I figured that I was gonna get like an actual like whole bunch of like actual like output from a prompt like this, and I did. Like this is exactly what I was hoping for as far as an output, honestly. I'm not going to read it out. You can, if anyone wants to read it, but so like you can see like very clearly a few things within this. Like first of all, it's like the model is going to just put out whatever it's trained on the most, and then so if you're pumping it full of Reddit data, it's going to like essentially give you like a conglomeration of like the pattern of Reddit data. So I think if we're talking about the pattern of Reddit data, I don't think I can come up with a more perfect example than what we're looking at here. If you just simply like read through what the outputs are of the model, but so I think that's interesting, very interesting in and of itself. But then the other thing to note is that it's like for research, I mean, for beyond research purposes, like there's not a lot that you can do with a model that can't really generalize like past this. Like, let me show you a better example, such as like our widgets. Let's do like price of our widgets is too high. Set the customer. So this would be like, kind of a real world like instance that you would want it to do, and it's going to take about 45 seconds or so to generate through here. So that's one thing to note. Like it's not going to be like the quickest model in the world, but it's also not the slowest. So it took a lot quicker than I thought. Right? So the price for widgets is too high, said the customer, and we agreed. The customer's widget was not going to be the one to make it big, so we're happy to cut our losses. Here's the first of 3 versions of the widget. The price is too high. We can't make money off of it, but we think it's a good design. Here's version 2. We took the price down to $1.95. Not great, but we're happy to take $1.95. And here's version 3. We reduced the price to $1, and we agreed. We were right. The widget was a flop. The customer wasn't a bad guy. He just didn't have the vision to see that his widget would never make it. But we do. And we're willing to cut our losses and move on to the next widget. The only thing we don't see is the next widget. Maybe we should ask our customer for advice. But that would be too easy. We're better off just to stay in our comfort zone. We'll never make it big. So out of all of the outputs that we've seen here in the model, like none of these are actually like coherent outputs, right? Like I wouldn't utilize this model like actually for any like, actual purposes. Like what is this model actually good for? But if we go back again to like the GitHub, we can see that it essentially like is what they're trying to claim with it is that it's like benchmarking like hugely off the charts, right? They're like, oh, it's I mean, they're not making the claim directly, but it's how they present, and it's often presented like this is a knock on stable LM specifically. This is a knock just on anyone that is putting this out, and I guess like. How else do you benchmark it, right? So I guess it's really not a knock on anyone, it's a knock on benchmarking itself. But like, what do these do? Like, what, I mean, okay, so it's averaging 66.93. The ARC is a 37.8, which is a little bit worse than Falcon 7B. Like Falcon 7B is like running at 40.27, and this is a 42.24. But when I run Falcon 7B as opposed to running this stable 3LM3B model, I can actually get like valid outputs from that Falcon 7B model. It's kind of clean, whereas I'm not from the 3B model. So it's, I have those kind of questions there. And so the big overall take that I have with this model and what I've noticed is models in these classes. So I guess, first of all, my overall review, I would actually review Phi 1.5 better than stable LM3B. If I were to use a model in like uh, the 3 billion parameter or lower class, I'm still choosing Phi 1.5. I don't think anything else has topped it. But with that being said, I wouldn't utilize a model in the sub 3B or sub 3B class. That's what I figured out. The models don't have enough parameters at that point to generalize more than like enough that you need them to. So I guess to me, like we should split what generalization means. Like there's uh, generalization in the sense that yes, this model can generalize text, but then there's advanced generalization. Like going back to the very stark example, this very basic example, right? Like where I ask it, like it was a dark and stormy night. It should be able to generalize enough. Like a more advanced generalization would be if I asked like Bard or ChatGPT, it was a dark or stormy night, and I prompted it with that, it would obviously know that some sort of derivative line of that, and then it would be able to continue that story directly. Whereas like this model is able to generalize enough to create only coherent text, but not coherent text that is like actually directly related to it was a dark and stormy night, right? Like that's kind of the difference I'm trying to make there. It's like there's a layer missing with these models that they can't do at this parameter level. I think that's kind of my analysis that I've drawn here with these models, and I'll continue to research models in this range and back that up. But after playing around like very significantly with every model that's come out in this range now, I can kind of like very clearly formulate that conclusion. And then so that's kind of like the big thing that I draw from this is like there's something missing with 3 billion parameters that's there at 7 billion, that like necessarily you don't need to go higher than 7 billion so far that I've found in my research. And that's kind of where I'm at with all of this at the moment. If you like this type of content, please like and subscribe. Thank you very much.